Hello, my name is Daniel, and today we will be going through the AMC 12A from the year 2005. So let's get started. First problem, 2 is 10% of x and 20% of y. What is x minus y? So 2 equals 1 over 10 of x, and which also equals 1 over 5 of y. So this gives us x equals 20 and y equals 10. So x minus y, that's 10. The answer is 10, which is D. Number 2, the equations this and this have the same solution. What's the value of b? Okay, so let's first get the solution of that. That is 2x plus 4 equals 0, so x equals negative 2. If we plug this into here, then that gives us negative 2b minus 10 equals minus 2. So negative 2b equals 8. b equals negative 4. The answer is negative 4, which is b. Number 3, a rectangle with diagonal length x is twice as long as it is wide. What is the area of the rectangle? Okay, so if we draw a rectangle like that, we have diagonal length x, so this will be x, and then it's twice as long as it's wide, so this will be a, and let's say this is 2a, right? Then so looking at this right triangle by the Pythagorean theorem, we get that x equals root of 2a squared plus a squared equals root 5a, right? And so the area of the rectangle, that's 2a squared, right? So 2a squared equals 2 over 5 times 5a squared, which is 2 over 5 times x squared, right? So it's 2 over 5 x squared. So this is the answer. It's B. Number 4, a store normally sells windows at $100 each. This week, the store is offering 1 free window for each purchase of 4. Dave needs 7 windows and Doug needs 8 windows. How much will they save if they purchase the windows together rather than separately? So if they purchase it separately, Dave will pay for 7 minus 1, so that will be 6 windows. Doug is going to pay for 7, right, which is 8 minus 1, right, because he can only get 1 free window because he purchases because if Doug purchases 4, then he will get 1 free, and he just needs 3 more, and that's not 4, right? So he will have to purchase 7. So in total, have to purchase 13 windows, right? But then if they buy it together, then Dave plus Doug, they will both need 4 plus 8. Sorry, they need 7 plus 8, which is 15, and so they will pay for 12, right? Because if they pay for 12, then they're gonna get 3 free, so that's just gonna all be 15. So this means that they pay for 1 less. So 13 and 12, that's difference of 1. So they pay for 1 less, which is $100 saved, right? So the answer is $100. It's A. Number 5, the average, which is the mean of 20 numbers, is 30, and the average of 30 other numbers is 20. What is the average of all 50 numbers? Okay, so let's just have the total sum of all the numbers, which is 20 times 30 plus 30 times 20. That's equal to 1200, right? And we have 50 numbers total, so the average of 50 numbers is 1200 over 50, which is equal to these two cancel, and that will be 24. So this is the answer. It's 24. It's B. Number 6, Josh and Mike live 13 miles apart. Yesterday, Josh started to ride his bike towards Mike's house. A little later, Mike started to ride his bicycle toward Josh's house. When they met, Josh had ridden for twice the length of time as Mike and a 4/5 of Mike's rate. How many miles had Mike ridden when they met? Okay, so since Josh rode at 4/5 of Mike's rate, let's say that Josh went at 4 miles per hour, and Mike went at 5 miles per hour, right? And since we also don't know the length of time that they rode, let's say Josh rode for 2x hours, and Mike rode for x hours, right? Because Josh rode for twice the time as Mike, right? And if we multiply that together, we will get the distance that each of them rode. This is equal to 8x. This is equal to 5x, and if we if we add that, that's 13x, right? And they are 13 miles apart, so 13x equals 13, so x is equal to 1, right? So how many miles had Mike ridden? So we want the miles that Mike rode, so that's 5x miles, and since x is 1, 5x is going to be equal to 5 miles, right? So the answer is 5 miles. It's B. Number 7, square EFGH is inside the square ABCD so that each side of EFGH can be extended to pass through a vertex of ABCD. Square ABCD has side length root 50 and BE equals 1. What is the area of the inner square EFGH? Okay, so we know that this much is root 50, right? So that's root of 50, and b is 1, so that much is 1. And since this is 1, this is the same length, so that's also 1, right? And now we can use the fact that this is a right triangle with this as a right angle. So this square plus this square would equal to this square, right? So root 50 squared, so that's just 50, is equal to 1 squared plus, let's say EH is a plus 1 squared, right? And then this is going to be equal to 49, so a plus 1 equals 7, a equals 6, right? So a is going to equal 6, and so this is all going to be 6 because it's a square, right? And then we want the area of the inner square EFGH, so we want this area, so that's just this times this, which is 6 times 6, right? So 6 times 6 equals 36. This is our answer, it's C. Number 8, let A, M, and C be digits with this much times this much equals 2005. What is A? Okay, so if we see here, this 100A plus 10M plus C, this is just a 3-digit number, right? And this A plus M plus C, this is the sum of the digits, right? Sum of the digits. And so all we have to do now is separate 2005, and so since we can just see that it's a multiple of 5, that would be 5 times 401, right? But then right away we can see that 4 plus 0 plus 1, the sum of the digits, is equal to 5, which is the sum of the digits, right? And so that means that 401 must be the 3-digit number, and this 5 must be the sum of the digits. So we want A, which this is the number in the 100th place, right? 100th place. And that number is 4. So the answer is 4. It's D. Number 9, there are two values of A for which the equation 4x squared plus ax plus 8x plus 9 equals 0 has only one solution for x. What is the sum of these values of A? Okay, so if we just combine that gives us 4x squared plus a plus 8x plus 9 equals 0. And since it has only one solution, that means the determinant equals 0. So b squared minus 4ac, that is a plus 8 squared, a plus 8 squared minus 4 times 9 is equal to 0, right? So a plus 8 squared equals 4 times 9, which is equal to 16, which is 16 times 9, and this is 144, which is 12 squared, right? And so a plus 8 is going to be equal to plus or minus 12, so a is 12 minus 8, or negative 12 minus 8, right? And we want the sum of the values of a, and so if we sum these up, these two are going to cancel, so that's going to be negative 8 times 2, which is just equal to negative 16, right? So the answer is negative 16. It's A. Number 10, a wooden cube, n units on a side, is painted red on all 6 faces and then cut into n cubed unit cubes. Exactly 1/4 of the total number of faces of the unit cubes are red. What is n? Okay, so first let's look at the number of total faces. It is cut into n cubed unit cubes, right? So this is going to be equal to 6 for each face, times we are going to have n cubed number of cubes, so that's n cubed. So 6 times n cubed, right? And then the number of red faces, this is going to be equal to 1 cube, so it's going to have 6 sides, and then it's n units on a side, so one side is going to have n squared, right? So this is 6 times n squared, and so so this ratio, that is this over this, right? So it's 6 times n squared over 6 times n cubed. This is equal to 1/4. It's 1/4, and these two cancel, so 1/n. That means n equals 4. So 4 is the answer, it's B. Number 11, how many 3-digit numbers satisfy the property that the middle digit is the average of the first and the last digit? Okay, so let's say that the 3-digit number is ABC, right? 100A plus 10B plus C. Then we are going to have that 2B equals A plus C, right? And so if we list possible values of B, B can be just everything from 1, 2, 3, 4, 5, 6, 7, 8 up to 9, right? And so if B is 9, then how many values for A and C can we have? If B is 1, then 2B is going to be, I'll just make a separate line for 2B here. 2b is going to be 2, so A and C we can have 1 1 or 2 0, so 11 or 20, and we can't have 0 2 because that's not yeah, so 0 can't be at the first, right? Yeah, so that's going to give us two ways with 1 1 and 2 0. And for 2 we can have 4 ways, right? Because 2b is 4, and so we can have 1 3 2 2 2 3 1 and then 4 0, so that's 4 ways. And for 3, 2b is 6, so we can have 6 ways. By the same way, we have 1 something, 2 something, all the way up to 6 0, right? And then for 4, that's the same thing. We have, since 2b is 8, we have 8 ways. 1 7 2 6 all the way up to 8 0, right? So those are for 1 2 3 4, right? So that's this much, that's this much. And then for 5 we can have 2b is 10, right? So A and C can be 1 9 and then 2 8 all the way up to 9 1. So this is going to be 9 numbers, and we can't have something with a 0 because then, like, are you going to have 10 0? That's not making sense. So this is going to have 9 ways, right? And then for 6, 2b is 12. So from here, it's safest to go from first digit being 9 and then go backwards. So we have 9 and then 93, right? And then so 9 8 7 all the way up to 39, right? Because that's just this backward. So this much is that's 7 values. So we have 7, and for 7, 2b equals 14. So this is gonna give us 9 5 up to 5 9, so this is 5 values. And so by the same thing, this is 16, so we have 3 values. And of course for this one we're just going to have 9 possible. That's just one value. And so if we add up all of this, 2 4 6 8 1 3 5 7 9, this is just the sum from 1 to 9, right? So that because it's 1 2 3 4 like that all the way up to 9, so this is equal to 45. The answer is E. Number 12, a line passes through A 1, 1 and B 100, 1000. How many other points with integer coordinates are on the line and strictly between A and B? Okay, so since we want the points with integer coordinates, right, then it will be okay if we move all the points one left and one down, right? And so A, this is going to become 0, 0, and B is going to become 99, 999, right? And so our line is going to be y equals, and then the slope is 999 over 99, which is 111 over 11, and then so this is going to be our line. And so our possible points, not including these, are going to be 11, 111, and 22, 222, and then 33, 333. You see the pattern here. This is all going to continue up to 88, 888, and then after that is this value, so that's not possible. We have in total 8 values, so the answer is 8. It's D. Number 13, in the 5-sided star shown, the letters A, B, C, D, and E are replaced by the numbers 3, 5, 6, 7, and 9, although not necessarily in that order. The sums of the numbers at the ends of the line segments A, B, B, C, C, D, D, E, and E, A form an arithmetic sequence, although not necessarily in that order. What is the middle term of the arithmetic sequence? Okay, so since we have the sum of the line segments A, B, B, C, C, D, D, E, and E, A, so this whole sum, so the sum of the numbers in the arithmetic sequence, they are just each number counted twice, right? Counted twice, right? So this is going to be 2 times 3, 5, 6, 7, 9. So 3 plus 5 plus 6 plus 7 plus 9. And that's going to be equal to 2 times 30, which is 60. And so 60 is going to be the sum of all the numbers in the arithmetic sequence. So our median, so our middle term, that's going to be the median, is 60 over 5, right? Because it is also the mean. This is equal to 12. So that's our answer. The answer is 12. It's D. Number 14, on a standard die, one of the dots is removed at random with each dot equally likely to be chosen. The die is then rolled. What is the probability that the top face has an odd number of dots? Okay, so let's first see the whole number of dots. So the sum from 1 to 6, 1 plus 2 plus 3 plus 4 plus 5 plus 6, this is just 7 times 3, right? So this is equal to 21 dots in total, right? And then if we remove a dot from 1, 3, or 5, right, then the probability of this happening is 1 plus 3 plus 5, which is 9, 9 over 21 dots, and then this multiplied by, and then we will have, so we will have 2 odd and 4 even left over, and so that's gonna make it possibility of the odd number would be 2 over 6, right? So this is gonna be equal to 3 over 7 times 1 over 3, which is which is just 3 over 21. And same thing, if we remove it from 2, 4, or 6, then that's gonna be this, together it's 12, so it's 12 over 21, and then that's gonna be this times, and then now we're gonna have 4 odd and 2 even, right? So that's gonna get us 4 over 6. So this is gonna be 4 over 7 times 2 over 3, so this is 8 over 21, right? And so all this together, this gives us 11 over 21. So this is the sum, it's our answer. The answer is D. Number 15, let AB be a diameter of a circle and C be a point on AB with 2 times AC equals BC. Let D and E be points on the circle such that DC is perpendicular to AB and DE is a second diameter. What is the ratio of the area of triangle DCE to the area of ABD? Okay, so since we know that 2 times AC equals BC, right? And so if we have a line from E right up to there, like that, then this will be the same length, right? So let's say that this point is point F, and then now if we look at DCE, the vertices of DCE, and if we bring this one up like that, then this new triangle of DCF, so this triangle, that will have the same area as this DCE triangle, right? Because if we see that this is the base and this much is the height, right? Then that's equal for DCF as well as DCE, right? And so the area of DCF, that's what we want to get. So DCE, this equals, so this equals DCF, right? And then now if we compare ABD and DCF, we have ABD and DCF. So our heights are the same. So ABD and DCF, the heights are the same, but then, so the ratio of the areas is just the area of the bottom, right? And then we have said before that AC equals CF equals BF, right? So DCF over ABD, this is going to be equal to CF over AB, which is 1 over 3, right? So 1 over 3 is the answer, it's C. Number 16, 3 circles of radius S are drawn in the first quadrant of the xy plane. The first circle is tangent to both axes, the second is tangent to the first circle and the x-axis, and the third is tangent to the first circle and the y-axis. A circle of radius R is greater than S is tangent to both axes and to the second and third circles. What is R over S? Okay, so we're going to just draw some lines here. First of all, since these are connected, we obviously want to draw lines from center to center, right? Like that, and then from the center to the bottom, and then we're going to draw a line like that, that goes through the centers, and then one more line just like that, right? Like this. And so now we are going to focus on this triangle over here. This triangle, that's also a right triangle, like that, right? And so since this much is R, that means this much is also R, right? But then since one radius is S, that's S, this is S, and that means this is also S, and since these and these two have the same length, this is also S, right? So this much value, that is R minus S, right? So this is R minus S, right? And then now let's look at this one. That will be a 45 degree, so that will be a 45, 45, 90 right triangle, right isosceles triangle. And so this length and this length, that will be equal, right? So this thing will be R minus S. But then see also that these lengths, they are also radii of the smaller circle. So if you see, this is R minus S, and this is 2S, right? And so this angle, that length, this is going to be R minus S minus 2S, right? This equals R minus 3S, right? So this is going to be R minus 3S So this is r minus 3s, right? And then lastly, let's look at this length. This length is just equal to this length, which is just s, plus this length, which is just r, right? So this is just r plus s. And so if we write that again, this is going to be, that's going to be r plus s, right? And so r over s, that's going to be r plus s squared is going to be equal to r minus s squared plus r minus 3s squared, right? And so this is going, so that was from the Pythagorean theorem. And so if we expand it, then r squared plus 2rs plus s squared equals r squared minus 2rs plus s squared plus r squared minus 6rs plus 3 plus 9s squared. 9s squared, and so these two are going to cancel, these two are going to cancel. So 4rs equals r squared minus 6rs plus 9s squared, so r squared minus 10rs plus 9s squared equals 0. And so that's going to give us r minus 9s, or times r minus s. So r equals s, or so r equals s, or r equals 9s, right? And since this cannot be possible, since r is greater than s, right? So that's not possible. That means r is equal to 9s. And so if we want r over s is going to be 9s over s. So this is going to be equal to 9, right? So this is 9. The answer is D. Number 17. A unit cube is cut twice to form 3 triangular prisms, 2 of which are congruent as shown in figure 1. The unit cube is then cut in the same manner along the dashed lines shown in figure 2. This creates 9 pieces. What is the volume of the piece that contains vertex W? Okay, so this is vertex W, and for the piece that contains that would have this outline. So it would be this one, right? That would be this one. So to get the volume of that, the volume is going to be equal to 1/3 times base times height, and we know that this much is the base, right? And it's 1/2 by 1/2, so it's 1/3 times 1/2 times 2. Sorry, 1/2 times 1/2, which is 1/4. And then the height. Sorry, this is supposed to say height. That's going to be this one, which is just 1, right? So times 1. So this is going to be 1/12. So this is the answer. It's A. Number 18. Call a number prime-looking if it is composite but not divisible by 2, 3, or 5. The 3 smallest prime-looking numbers are 49, 77, and 91. There are 168 prime numbers less than 1,000. How many prime-looking numbers are there less than 1,000? Okay, so since we have 1,000 total values, but then we have 168 prime numbers less than 1,000, so our prime-looking numbers, this will be equal to 1,000, right, minus 1, and this is just for the value of 1 itself, because 1 is neither prime nor composite, so it's going to be 1, 4, 1, right? And then we're going to have to take away the number of primes, but then with 3 subtracted from them, right? And this 3 is because 2, 3, and 5 are going to be included later, right? And then lastly, we have subtracted by the numbers that are divisible by 2, or 3, or 5. And so since we know that there are 168 prime numbers, then this would be 168 minus 3, so that would be 168 minus 3, which is 165, right? 165. And so this is all going to be equal to 1,000 minus 166, so that's just going to be 834. So this is 834 minus, and then divisible by 2 or 3 or 5, minus divisible by 2, 3, or 5, right? And so now we have to get this value. So being divisible by 2, 3, or 5. Yeah, so I should make it clear. This is 2 or 3 or 5, right? So this is going to be everything. Yeah, so this is going to be the number of numbers that are divisible by 2, plus the numbers that are divisible by 3, plus the numbers that are divisible by 5, minus the numbers that are divisible by 6, right? Because those are overlaps between those two, minus the numbers that are divisible by 10, because that are overlaps between these two, and then minus the numbers that are divisible by 15, because that are overlaps of these two. And then lastly, we have to add the numbers that are divisible by 30 because we subtracted all three of those 30s, and so we have to just add one again to make up. And so this is going to be equal to 1000 divided by 2 is 500, so we have 500 plus 1000 divided by 3, that would have a quotient of 333, and this would give a quotient of 200, minus this would give a quotient of 166, this would obviously give a quotient of 100, and this would give a quotient of 66, and 66, and lastly this would give a quotient of 33. And so this is all going to be equal to, this much is 1033, and then this much is 2 times 166, which is minus 332, and this is just plus 33, so that's just going to be 1066 minus 332, so this is going to be equal to 734, right? And so divisible by 2 or 3 or 5, this is going to be 734, so this is going to be equal to 834 minus 734. This is equal to 100 numbers, so this is the answer. It's 100. It's A. Number 19. A faulty car odometer proceeds from digit 3 to digit 5, always skipping the digit 4 regardless of position. If the odometer now reads 002005, how many miles has the car actually traveled? We are supposed to have numbers from 0 to, yes, so numbers from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are supposed to have 10 numbers, right? But then we always skip the digit 4. That means just one number. This is just never going to exist, right? And so that's just equal to saying that this is a base 9, right? So we have 2005 base 9, 2005 base 9. No, sorry. It's actually 2004 base 9, right? It's actually 2004 base 9 because 5 was just a skip of the digit 4, and so 5, this actually means 4, 6 actually means 5, 7 actually means 6, and 8 actually means 7, 9 actually means 8, like that, right? And so since 5 actually means 4, this is just the same thing as 2004 base 9, and so this is going to be equal to just 2 times 9 to the 3rd power plus 0 plus 4 times 9 to the 0th power, so that's just plus 4. So this is 1458 plus 4, which is 1462, right? So 1462 is the answer. It's B. Number 20. For each x in 0, 1, define fx as 2x if x is between 0 and 1/2, and 2 minus 2x if x is between 1/2 and 1. And so let f of 2 of x be f of x, and fn plus 1x, this will be fn of fx, right? And for how many values of x in 0, 1 is f 2005 of x equal to 1/2? Okay, so this one we have to work backwards, right? And so if f 2005 of x is equal to 1/2, right, then this can go two separate ways, which is if x is between here or if x is between there. So it can go 1/4 or x is equal to 3/4. And from each of these values, same thing, we can go half, we can go two values like that. And from that, we just keep branching on by 2 values. And so if you see, this is just every value is multiplied by 2, right? So it's 1 times 2 times 2 times 2, and then times 2 of that, times 2 times 2 times 2 times 2, like that. And so this is all just going to increase exponentially by powers of 2, right? So that's f 2005 of x. So this multiplying by 2 is going to be done 2005 times, right? So this is going to be equal to 2 to the 2005th power. So this is the answer. It's E. Number 21. How many ordered triples of integers a, b, c with a is greater than or equal to 2, b is greater than or equal to 1, and c is greater than or equal to 0 satisfy both this and this? Let's just take away the log here. So let's just make it b equals a to the c to the 2005th power's power. 2005 power, like that, right? And so we have three possible three possible ranges for c here. C can be 0, C can be 1, or C can be greater than or equal to 2. And so first of all, if C is greater than or equal to 2, then this is going to be like some huge number. And since A must be greater than or equal to 2, that means this is going to be a huge number. So it's obviously going to be greater than 2005. So that can't be it. That means C cannot be greater than or equal to 2. So C must be either 0 or 1, right? So first, if c is 0, then that will mean b equals a to the 0th power, which is 1. So b is 1, and therefore, since a plus b plus c needs to be 2005, a would equal 2004. So that's possible. And for this one, if c is 1, that means b is equal to a to the 1st power, and so b equals a, and so this needs to be summed to 2005, but c is 1 already, so they are equal to 1002, right? So we have two ways of happening, so we have 2 ways. The answer is C. Number 22. A rectangular box P is inscribed in a sphere of radius r. The surface area of P is 384, and the sum of the length of its 12 edges is 112. What is r? Okay, so let's bring out a diagram of this rectangular box here, right, like that. And then since it is inscribed in a sphere of radius r, that means the center of this box is going to be the center of the sphere, and the longest length, so that's going to be the diameter, right? So that's the diameter, which is 2r, right? And let's say that the length of the edges, they are A, B, and C, right? So since the surface area of P is 384, so 2 times AB plus BC plus CA equals 384. So so that's one equation we have. And the one more is that the sum of the length of its 12 edges, so 4 times A plus B plus C, this is equal to 112, right? So from this one, we can see that A plus B plus C is equal to 28, right? And then since we know that A plus B plus C squared is equal to it's equal to A squared plus B squared plus C squared plus 2AB plus BC plus CA, and so this is equal to 28 squared. 28 squared equals A squared plus B squared plus C squared, plus this is equal to this thing, so it's 384. 384, that means A squared plus B squared plus C squared equals root 784 minus 384, so this is root 400, this is 20. And so since this is 20, but then if we look at 2r, we see that this length, that is, this length is root b squared plus c squared, so 2r must be equal to the root of a squared plus b squared plus c squared, right? And so now we know the value of a squared plus b squared plus c squared, then r is equal to all over 2, and then the root of this thing, which is 400, right? So it's the root of 400. This is going to be equal to that's going to be equal to 20 over 2, which is 10. So 10 is the answer, it's B. Number 23, 2 distinct numbers A and B are chosen randomly from the set this, right? What is the probability that log a to the b is an integer? Right, so what this basically means that if A and B are chosen from the values 1 to 25, right? Then we want the probability that b over a is going to be an integer, right? And then since they have to be distinct, a should not be b. And so from this, then what really matters is what value a is, right? Because if we have the a value, then the possible b values, they are automatically set, right? So let's say that a equals 1, and a can just equal everything from 1 to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, up to 12, right? Because if a is greater than 12, then there is no number that b can be, because a always has to be less than b for it to be an integer, right? Less than or equal to b. If a is 1, right, then the values of b is just everything, right? So we have 25 possible values of b, and then so let's not consider this for now, and let's say that if a can equal b, so if a can be equal to b, b would have 25 possibilities, and 2, that would have 12 possibilities, right? Because 25 divided by 2 has a quotient of 12, and since 25 divided by 3 has a quotient of 8, so this is 8. 25 divided by 4 has a quotient of 4, so that's 6. And so this 5, quotient of 5, that would be 5. This would be 4. This would give us 25. 7 times 3 is 25, so we have 3. 8 times 3 is 24, so we have 3. 9 times 2, so that's just 2. 10, 2, 11 got 2, and 12 got 2, right? And so now if we add these all together, these two would be 10. These two, yeah, so that would be 10. Those four would be 10 also, right? Because it's 5 plus 5. So that would be 10. This would be 30, right? And then 5 plus 25, that would be 30. Sorry, this isn't 30, that's 20, right? That's 20. And then this would be just 4. And so if we add them all together, that would all be 74 in total, right? But then note that we ignored this one. And so if we look at that now, then a cannot be equal to 2. And since there are 12 values for a, then for each one, there must be 12 b values that are equal to a. So we have to subtract 12, right? Because this is when a equals b. So this is going to have 62, right? So we're going to have 62 total possibilities. So it's 62 over, and then what's the total possibilities? We can choose out of 25, and then we can choose A or B, right? So that's 25 times 24. And so this is going to be equal to 62 over, yeah, sorry, that's, if we divide by 2, this is going to be 31. That's going to be 31, and this is going to be 12. So this is 31 over 25 times 12. This is equal to 31 over 300, right? So this is the answer. It's B. Number 24, let px equal x minus 1, x minus 2, x minus 3. For how many polynomials qx does there exist a polynomial rx of degree 3 such that pqx is equal to px times rx? Okay, so from using that, we can get the degree of q, right? Since p is a third degree, right, and r is also a third degree, right? That means p times r. This is going to be 3 plus 3, which means it's a 6th degree. And since for PQX, P is 3, and then Q is we don't know. So this is going to be equal to PQ of X, right? PQ of X, like that. And so Q of X, this is going to be equal to 6, this 6, over 3, because PX is a third degree. Right, so this is going to be equal to 2. So qx is going to be a second degree, right? And then now let's get into the problem. If we write out pqx equals px times rx using px equals that, that's going to give us qx minus 1, qx minus 1, qx minus 2, qx minus 3. Minus 3. This is equal to x minus 1, x minus 2, x minus 3 times r of x, right? Times r of x. And then if x is 1 or 2 or 3, then the whole thing is 0, right? So if x is 1 or 2 or 3, then the whole thing is 0. One of these must be 0, right? And so we have 9 possibilities. One is when q1 equals 1, so that's when x is 1 and this is 0, right? So q1 equals 1, or q1 can equal 2 when x is 1 but this is 0, and q1 can equal 3 if this is 0, right? So 1 or 2 or 3. Same thing for q2 and q3, right? q2 can be 1, 2, or 3, and q3 can be 1, 2, or 3, right? And so we have 3 possibilities for each x value of q. So in total, we are going to have 3 cubed, which is 27 possibilities, right? But then that's not the answer, because from these, we have some values of q. Because we have some qx's. So some qx's are not a second degree, right? And this is if q1 equals 1. Q1 equals 1. Q2 equals 2, and q3 equals 3, right? Because then q would just be, because then q would just be x, right? And that's a first degree, and so that's not possible. And in the same way, q4 would equal 3. What if q1 equals 3 and q2 equals 2 and q3 equals 1? Then that would mean that q equals 4 minus x, right? And this is also a first degree, so that is not possible. And there are other values of q. Yes, and there are other possible Q's that are not second degree. Let's say if Q1 is 1, and Q2 is also 1, and Q3 is also 1, right? That means for one y value, there are 3 x values, so 3 roots. But then if this is a second degree, that's not possible. It must be a third degree, right? So Q is a third degree. Q is a third degree. Same thing if Q1 equals 2, and if they all equal 2, then it's also going to be a third degree. If they all equal 3, that's certainly possible, then it's going to be a third degree. We can see that these 5 Q's, they cannot be part of these 27, right? So what we now have to do is 27 minus the 5 of this. So it's 27 minus the 5 of that, which is equal to 22, right? So 22 possible, that's the answer. The answer is B. Number 25. Let S be the set of all points with coordinates x, y, z, where x, y, and z are chosen from the set 0, 1, 2. How many equilateral triangles all have their vertices in S? Okay, so first let's just look at the case of one unit cube. So just for one unit cube, that would just be, we would have those like that, right? And so in total, we would have vertices at here, 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 right? So 8 in total. For each vertice, you can have an equilateral triangle that has that in the center, right? So we can have this triangle for this one, and for this one, we can have this equilateral triangle, right? That has this in the center. So since we have 8 vertices in total, we have 8 triangles for each cube, right? And since XYZ can be 0, 1, 2, that means their possibilities are like that, and so this would be the whole set, and then it would be divided like this into 8 possible cubes. So this is going to be 0, 1, 2, or 0, 1, 2, and then this far side, that's going to be 0, 1, 2, right? So this is going to be 1, 2, like that. And so the point is that it's going to be a 2 by 2 by 2 cube. First of all, if we just look at the number of 1 by 1 by 1 cubes, like this one, then we would have 8 1 by 1 by 1, 1 by 1 by 1 cubes, and we have 1 2 by 2 cube. That's just the whole thing. 1 2 by 2 by 2 cube, and so these would give us 9 cubes. 9 times 8 triangles in each cube, right? So 9 times 8, this equals 72. Right? But then 72 is not the answer because we have more. If you look at here and here and here, if you connect those lines, right, then that would make an equilateral triangle that has this at the center. We have this triangle, or we can have the same thing but like kind of at different angles, so like right here. So this will be one more triangle with the center at this one, right? And so we have 2 for each vertice times 8 vertices in total. The one that's centered at this vertice is going to be equal to the ones that are centered at this vertice, and the ones that are centered at this vertice is going to be equal to the ones centered at this vertice, and so on like that, right? So we have to divide by 2 because one pair of vertices are going to have the same thing. So we have to divide by 2. This is equal to 8, right? So to this 72, we have to add 8 more. So if we get them all together, this equals 80 in total, right? So the total is 80. The answer is C. So that was the AMC 12A from the year 2005, and thank you for watching.